So good afternoon, everyone. Rain at the exact time. Okay. And it's raining very heavily. Like, and this is like one thing which I told you some days ago also, like nowadays we are having so much rainfall in Delhi. Like almost every day we are having rainfall. In the morning also there was rainfall, night also rainfall, evening also. Okay. It seems we have come near Meghalaya. Okay. So and now there is one thing, like despite this rainfall, we are having water scarcity in like most of the districts of India. Around 600 million people in India living in water stress, and rest are in the stress due to rainfall. Yeah. 600 million due to stress from rainfall, and 600 million. This is exact the figure. Actually, if you look at this, 600 million people are having some losses due to rain per year. This is the latest data which was there, around 600 million people. And remaining 600 million people, they are suffering from water stress. Okay. So both the things are going on simultaneously. If you have seen last or perhaps day before yesterday, there was this editorial which was suggesting the same thing. It's 600 million water stress, 600 stress due to water. Okay. Now, what we have discussed in the last session, light. Okay. So we have started with this one chapter that what is light. We have seen light is both acting as a matter also, it is acting as a wave also. We have seen it is a source of energy which enables us to see anything. When we see that light is incident on any surface, there is a chance of reflection, there is a chance of refraction, absorption, and when absorption is there, there is also a chance of radiation. These are some basic things which always take place whenever light is incident on any surface. Now, there are other things also which we have to consider here. We will see the part of refraction, that how refraction is responsible for different phenomena, different things in our nature. Many things which we see or which we assume that it is there, it is just because of refraction. It is an illusion. It is an illusion due to refraction. So we will see that what are those illusions. In fact, there was a question in UPSC. They have asked this one time, which of the following are optical illusions? So UPSC has also asked on this part that which of them are optical illusions. They will not ask you which is caused due to like this is a reflection or refraction, but they will ask you something different. Yeah. So they have asked this one question that which of them are examples of optical illusion, and they have given multiple options. So we will try to see them one by one. Now, we have discussed this one part. Whenever we are talking about reflection, reflection enables us to see any object. We have also seen that whenever there is a reflection, there is exact same amount of energy which is released by the electrons. In case of reflection, there is no loss of energy. There is no such loss of energy, same energy goes back. Reflection also enables us to see any object's color as well. Normally it is the color of light only, but we identify that there are objects of different color. Now we will see this second part, the refraction. Last day I also told you this one thing, that in the case of refraction, why there is a bending towards the normal and why there is a bending away from the normal. So see here. Why there is a bending towards the normal or why there is a bending away from normal. We have discussed this part last day also. Now see here one thing. Suppose that the light is reaching to this part. This line is normal. It is an imaginary line. Whenever we draw it, it is an imaginary line. This is the surface. This is the surface. We have seen it last day also that the wave front is interacting here for the first time. The wave front is interacting here for the first time. And suppose if it is a dense medium, this is a rare medium, here we know that speed is higher. Speed is higher. And as it goes down, its speed is going to reduce. Why it will reduce? There are so many particles which are going to reduce, or due to density, its speed is going to decrease. But the speed doesn't decreases at all the points of the wavefront. At this point of the wavefront, this is called as a wavefront. This is one such wavefront. So at this one wavefront, we see that the speed is going to decrease here. At this point, there is going to be a decrease in the speed. Whereas the point which is here, there is not going to be any decrease because it has not met with the surface. Here it is the air only. So this one will be passing at a slow speed, whereas this one will come fast. So from here itself, we will see that the line will bend like this now. It has bended a little bit. Then again, there will be more bending. And finally, it will be moving in this manner. So the light which was supposed to go like this has actually bended here. It was supposed to go here, but it has bended. It is just because of the wavefront, which one is interacting first with the surface and which one is interacting later. So this is just because of this one part, the wavefront, that we can explain how this light bends when it goes from one medium to another medium. If we take the another example, here again, we are taking the upper one to be dense medium, lower one to be the rare medium. In dense medium, the speed is going to be lower. Because density is high, the speed will be lower. Now, as it passes, this is the line which is representing the surface. This is the line representing the surface. Now, when we look at this one surface, what we see that once this wavefront is crossing this surface, now this part of the wavefront will be moving at a faster speed. Okay. So here, from this point, the wavefront, it starts going like this. If we trace the actual motion, it was supposed to go like this. Okay. Sorry. The actual motion, it was supposed to go like this. But it has bended a little bit. Just I will have to show a little bit more bending. It was supposed to come like this, but from here it has bended. It has bended in a different direction. It has bended away from the normal. This was supposed to be the original path. This is the deviated path. So there is a deviation in the light when it is moving from a dense medium to rare medium. It is going away from the normal. Remember one thing, whenever you have to get, just see here. Now here there is one wavefront. This is the part A, this is the part B. When it is crossing from a dense medium, sorry, here we have the rare medium. When it is passing from rare medium to dense medium, this is portion B of the wavefront, this is portion A of the wavefront. Now if you look at this, once it is crossing, when it reaches here, when it is crossing here, when it is coming in this part, which one will enter first? The B is going to enter here first. Okay. The B will be entering here first. When B is entering here first, then what is going to happen? This is going to move at a slower speed, whereas the other one will be moving at a faster speed. Now, if both of them are coming directly perpendicular, if they are coming perpendicular to this line, then what will happen? Same. Okay. So if it is going directly in there, if it is going directly in that like direction, if it is going straight, all the wavefront will be meeting at the surface at the same time. So if a ray of light is passing through the normal, it will not have any such deviation. But that is something which is very difficult to achieve. You need to have one single ray which is passing in this direction. You cannot check it from your ordinary torch. Why not from ordinary torch? There is a simple reason. Light from the torch diverges in all the direction. If you have a single laser light having one single ray coming out of it, then you would be able to see this, that the light will pass in a straight line. Because then all the waves will be moving in the same direction at the same time. So that's why in the case of refraction, we have bending towards the normal or away from the normal. If light is following this one criteria, if the light is following this one criteria, so is it a wave or is it a particle? From here, what do we see it? Is it a wave or it is a particle? Wave. It is following the nature of a wave. Here we can see that it is following the nature of a wave. With the wave motion only, we can explain this bending. Okay. Now, there is one part. If we assume that there is a decrease in the speed, we can explain it both in the case of wave as well as in the case of particle. When we talk about just the speed, we can say that it is applicable in case of particle also. It is applicable in case of wave also. But when we see the direction, how the direction changes, it can be explained on the basis of wave motion. Okay. We can exactly get the idea on the basis of wave motion. So if we see this one example, we can assume from here also that light is acting as a wave. Okay. So first, this one part, I think you have drawn it. Write a little bit about this. Like, we are not going to write about this wave part, you have to just draw it. Just write a little bit about refraction, and then we will come to the phenomena which is associated with it. D stands for like density. Here, D stands for dense medium, and R stands for rare medium. Here again, D stands for dense medium. S stands for speed. Here we are seeing that the speed is, and here the speed increases. Laser light with single monochromatic ray can be used for this one part, perpendicular part. Okay. Write just one thing. When light passes from one medium to another medium, when light passes from one medium to another medium, one medium to another medium, its speed changes. Its speed changes due to change in density of the medium. Due to change in density of the medium. Next part. When light is moving from dense to rare, when light is moving from dense to rare, it goes away from the normal. Dense to rare, it goes away from the normal. Whereas, if it is moving from rare to dense, then it comes, then it comes towards the normal, then it comes towards the normal. अब देखो, there is one part जो एग्जाम के लिए इंपॉर्टेंट होगा कि what is the phenomena associated with refraction. Yeah. So in the phenomena part, we have one thing called as twinkling of stars. Twinkling of stars. Okay. Twinkling of stars. So what is twinkling? What is twinkling? Like normally you know that stars twinkle. So what is the meaning of twinkle? You always have like memorize this one poem, Twinkle Twinkle Little Star. Okay. So how many poems you have memorized in your class? Like 1, 2, 3, 4, 5. Even there is now pre-nursery, nursery, and KG. Okay. So how many poems you have memorized? Tim Timana. Okay. So twinkle means Tim Timana. Yes, that is the Hindi meaning of twinkle. तारे टिमटिमाते हैं. So what is the meaning of twinkling or timtimana? It means the brightness of light, sorry, the brightness of a star. Sometimes it like becomes too much bright. Sometimes it becomes feeble. Means the brightness increases and decreases. The brightness increases and decreases, and at the same time, if you continuously look at a star, we'll find that its position is also vibrating. It is also oscillating. It may appear to you, that the stars are changing their positions minutely. It's not that one is going from north to south. Okay. A minor change in its position. Thus, at the same time, it may appear that the stars, they are sometimes becoming bright, sometimes they are appearing as feeble. Brightness is increasing or decreasing. So that is what we call as twinkling of stars. So this is one part. Why do the stars twinkle? And what is the mechanism which is acting behind it? So just see this one thing. Suppose here we have a star. And here we are having a person who is watching at the stars. Normally what we see that the light should have come straight into this person. Normally light should have come directly to this person and he would have been able to see the stars. These stars are not just like a few lakh kilometers. They are beyond 30 lakh crore kilometers, even more than that. So they are not nearby. They are very, very far away from the entire earth. There are millions of, like some are like light years away, some are millions of light years away. From there, we are watching these stars. Okay. So their light is coming to us. Now, when we look at this, when this light comes to the earth's surface, the earth is also having atmosphere. Earth is also having this atmosphere. Now tell me one thing. The density of atmosphere, is it uniform? The density of atmosphere, does it changes with altitude? Where do we have more density? Near the surface? Okay. So we are having more density near the surface and we are having like decrease in the density as we are going up. Now think about this. From this star, multiple rays of light are going. Multiple rays of light is coming from this star. Now, we are just doing this one thing. Now, when we look at this one star, in the upper portion, it is rare medium. and here it is a dense medium. In the upper portion, there is a rare medium. In the lower part of atmosphere, there is a dense medium. So when the light is coming from here, can this light have a bending? Can this light also bend? Okay. So when this light is bending, it is this ray of light is coming to the person from this direction. Then the person will assume that perhaps the star is here. Perhaps the star is here. Okay. So some light, this light may also bend, it may go downward. Okay. Maybe this light can also come to the person. So he will see that the star is here also. So this is one part that we can see multiple position of the same star. We would be able to see multiple position of the same star. Now at the same time, there is one factor which is also called as wind. Can wind also impact the density of atmosphere? Wind can also impact it. So can it happen that sometimes this medium can become rare also? The medium on the lower side, can it have a difference in density from time to time? You know that there are times when we have temperature inversion also. The upper atmosphere becomes cooler. Upper atmosphere becomes warmer and the lower one becomes cooler also. Okay. So we see that there is a change in the density with the wind also. So sometimes the light which is coming downward, it can also reach to this person. Okay. So we will have multiple position of the same star. That is one part. We see that we are able to see multiple position of same star. Second thing, like let us say that at one point of time, at one point like 11 minute 1 second, at 11 p.m. 11 p.m. at 1 second, we are getting, let us say, 100 rays of light. Just an example. We are getting 100 rays of light. At second, we might be getting less. Let us say we are getting only 80 rays. Some of the rays have bended extra, they have gone downward. Some of has gone up. That may also take place. That due to change in density, sometimes we can receive more rays from the star. Sometimes we can receive lesser amount of rays coming from the star. Because the density is continuously fluctuating. The density is continuously changing. So sometimes we might be able to see more rays of light coming from the star, sometimes lesser number of rays coming from the same star. As a result of this, what we will see that variation in intensity or brightness. Variation in intensity and brightness. So this is one part. We see that there is multiple position, at the same time variation in intensity and brightness. Now, when we look at the stars, they appear to us as point size. If you see a large object, even if multiple lights are coming from there, like suppose you are seeing a moon. From moon also, when the light is coming to us, it is also changing. But we are not able to witness that change because moon is nearby. Moon is just at like 3,86,000 kilometer or 4 lakh kilometer. Moon is just at this distance. Moon is nearby. So what we see that if we are comparing moon, the light from moon when it is coming to us, we are able to see a bigger shape also. And even if light is varying a little bit, we might not be able to notice the change. But the stars, which are already appearing as point shape, which are like lakhs of light year away, which are millions of light years away, if there is a light which is coming from there, and even if there is a slight fluctuation, then you will find that it will start to feeble. We will see multiple position of the same star, sometimes bright, sometimes dim. Okay. So bright and feeble light will be coming from this. So that's why we are having twinkling of stars due to refraction of light in the atmosphere. Okay. So refraction and the density is responsible for this. Refraction and density is responsible for this twinkling of the stars. So this is one part how the refraction impacts it. So is it reality or is it optical illusion? Because stars do not twinkle. Stars are not twinkling. Stars do not have multiple variation in the light. And even if it is there, it is not noticeable to us. Because the stars are very, very far away from us. And we are able to see just the visible light of it. The other lights we cannot even see from there. So it is not that the stars are twinkling. Sun is also a star. Sun is also a star. So do you see the sun twinkling in the daytime? That sun is having twinkling. Sometimes sunlight is coming, sometimes not. Okay. So sun is a nearby star. We can see it. We can see it clearly and we can see the bigger shape and size of it. So that's why we think that sun is not twinkling or we don't see it twinkling. But in case of stars, since they are like very, very far away from us, so that's why we are seeing them to be twinkling because of their size. Just one example. Sometimes you may have gone on highway or any place, and if some smoke is rising up, a bike is coming to you from a distant position, you might find some fluctuation in its light also. Or like this is the rainy season. Okay. So when if you want to check it, go on your own risk, not advisable by me, but stand on any highway and try to see if a vehicle is approaching from a long distance. If it is coming towards you, you will find that even its light is going to fluctuate a little bit. Why it is fluctuating? Because density is continuously changing due to the rain. Rain is like sometimes it is scattering the light, sometimes it is refracting the light. So when you are seeing something through a smoke also or through rainwater also, then you will find some fluctuation. If they are at a distance of like 500 meter and 600 meter, then you are able to see the fluctuation. Think about this. They are not even in our solar system. They are far beyond it. So when we see them, it is going to like twinkle. It is going to have variation in the brightness. So that is first part, twinkling of the stars, which is an example of refraction. Okay. See, wind, about the wind part, you know that wind is continuously changing the density. Wind will bring humidity. Wind can bring dust particles also. Wind can bring the moisture laden air also. Sometimes it can bring the dry air also. So can wind cause variation in density? Yes, it can cause. This is one example. We will write about it. There is another example. There is one thing called as advanced sunrise and delayed sunset. Advanced sunrise and delayed sunset. So that is also one thing which is an example of refraction. Let us say sun is here. This one line is called as horizon. Horizon is the line, the imaginary line beyond which you cannot see. Like suppose when you are going out in an open field, when you are going in an area which is having no such buildings, you will find that at certain point the sky is meeting the ground. Okay. And beyond that you cannot see. Whenever you stand at any place, in cities when you stand you will see only buildings. Apart from that you will see nothing. But when you go in a field, in a large field, in a landscape where there is only plain areas, farmlands and that, So there you will find that there is a line where the sky seems to meet the ground. Okay. It always seems to us in this manner that at some point the sky is meeting the ground. So this line which you see, it is the horizon. Okay. This is the line which we call as the horizon. Now suppose that sun is below the horizon. When sun comes up, then only we believe that there is sunrise. We believe that when the sun is visible to us, then we call it as sunrise. Sun is always there. The sun neither rises nor sun rests. Okay. Sun is always there having the same light. Okay. It is the rotation of the earth which causes it. So you know this part, that suppose the sun is here, the sun is at this point, below the horizon, you cannot see the sun. But there is one case. The light is going in all direction from the sun. Some of the light is also coming in this atmosphere. When it is coming in this atmosphere, each sun rays, when they are coming in atmosphere, can there be bending of the light? Atmosphere has changing density. Atmosphere have a change in density also. So can it cause the bending of light in our atmosphere? So the sun rays bend from here and reaches to us in this manner. Now we have one simple ability. If we see the light, we always try to see it in a straight manner. Whatever light is coming to us, we always see in a straight line. So if a person is receiving the light at this angle, we will assume that the sun has risen. The sun is here. So this is the apparent sunrise. This is not the actual sunrise. This is the apparent sunrise. And normally what we see that there is a duration of 2 minutes, only 2 minutes. Okay. That for 2 minutes we are seeing the apparent sun. And after 2 minutes there is actual sunrise. So here there is an advanced sunrise by 2 minutes. What is the sunrise time currently? Any one of you waking up in the morning before 10 a.m.? And some people go to sleep at 6 a.m., 7 a.m. Okay. That is the one such thing which is very much prevalent in case of ORN. Like in old Rajendra, people go to sleep also at 4 a.m., 6 a.m., 8 a.m. This is the most lively place in that case. Okay. People are like waking up throughout the night. And I always have this one problem. I like at any point of time after 11 p.m. I sleep. It doesn't matter what is there, what is not there. It's 11, it's time to sleep. Sometimes when you go outside, then for 1 hour or 2 hours, you can still be awake. But if you ask me, my choice, by 11, you have to sleep. And it is not from this time, from the starting. Okay. When I was up to class 9th or 10th, I used to sleep by 9 p.m. Okay. 9, 9:30, maximum 10. There was a proper problem for me, like all my siblings, they used to sleep at 10. They were studying and studying. They were studying at till 10 p.m., 10:30 p.m. And by 9, I have that deep like sleep problem. As soon as it is 9 p.m., now I have to sleep. Here in ORN, what do we see? And even in Mukherjee Nagar also. Although Mukherjee Nagar have changed now entirely, but there was a time when the entire place used to be like lively throughout the day and night. You wake up at 4, you will find someone. Okay. You wake up at 2 a.m., you will find someone on the road. Okay. Same thing goes with ORN also. Sometimes like a few times I have come here in night also, like 2 a.m., 4 a.m., 6 a.m. Whenever I come here, I see someone will be there on the road. Okay. So this is one such lively culture of ORN. But what we see here, if you wake up someday in the morning, or if you go to sleep at late, like suppose you go to sleep at 7 a.m., then you might get this chance to see the sunrise 2 minutes early. Okay. So that is one possibility whatever be the time, you might be able to see the sunrise 2 minutes early. In Delhi, you will not be able to see this. Yeah. First thing, pollution. Second thing, buildings. Yeah. So due to these factors also, you might not be able to see this. But if you go to mountains, if you go in those areas where there is plain fields or mountains, then you might be able to experience this. So from tomorrow, don't start asking me this part that I have not seen the sun 2 minutes earlier. Okay. In cities and in habitation, this is not possible. But in plain fields, you can see this. So this is one thing, advanced sunrise, and same goes with delayed sunset. Even if the sun is going down, then also some rays will be coming and the person will assume that the sun is present over here. So that is also one part, the delayed sunset, which we see. So write about these two things. Differentiate कैसे करेंगे apparent and real में? करना ही क्यों है? Why do you need to differentiate between apparent and real? Write about this one part. First, twinkling of stars. It is an optical illusion. It is an optical illusion. It is caused due to following factors. It is caused due to following factors. It is caused due to following factors. First, the stars are very far away from us. The stars are very, very far away from us. The stars are very, very far away from us. Second part. The light coming from it, is passing through atmosphere which has variation in density, according to altitude. Variation in density according to altitude. Third part, the wind in atmosphere also changes the density of atmosphere due to factors such as humidity, dust particles, etc. Then after changing the para, as a result of variation in density, there is a variation in intensity of light. And deviation in the direction of light rays. So this is one part. Now there is one thing like there is one question that how does the speed decreases or increases automatically? How does the speed increases or decreases automatically? Okay. Just take an example. If suppose that in any case, you know that it is not about the light, it is about the electron which are passing the energy. The reflection, refraction, absorption, or anything. It is about how the electrons are passing the energy. Like suppose when we are talking about sound also, we see that in the case of sound, it is a mechanical wave which depends on the density of the medium. If the density is high, it means the speed will be faster. If density is lower, speed will be lower in the case of sound, which is just opposite to light. So how does it go? If it is a dense medium, how does the speed changes? The speed changes because if they are near, they can easily transfer the energy. If they are nearby, they can easily transfer the energy, and sound wave will be propagating at a very fast speed. Whereas when we talk about this gaseous medium, here the speed decreases because it will take the time from one particle to another particle to give this energy. So it is because of density that in the case of sound, the speed also varies according to the density. Now, in the case of light, it doesn't depends on the matter directly. It is not depending on the matter directly because it can pass in vacuum also. Why light can vacuum? Why light can pass in vacuum also? There are multiple theories, which starts with photon. That light is itself a photon, which is flowing through this because of the inherent energy, because of the energy inside it. Photon is called as an energy packet. It is a quanta. It has also been called as quanta, or small quantized packets of energy. So this is a packet of energy, and it is acting sometimes as a particle. It can move by itself. So when we talk about the light, light is made of certain things called as photon. This photon has the inherent energy, means it is a packet of energy itself. Now when this packet of energy is moving through any medium, suppose it is a very dense object, like let's say like the like we have this presence of the wall. So in case of wall, what we will see that it will collide with the wall and will go back with the same speed. Some energy will be absorbed here also, but there is a little chance that it will be able to pass through. Now suppose here we are having a glass. Now in the case of glass, the particles are not that much dense. If the particles were very dense, light would not be able to pass the energy through it. Glass will not be able to pass the energy through it. So when we are talking about the glass, what we see that when the particles are passing through this, it means the photon is passing through this. When the photon is passing through it, and if it is facing some disturbance in the air, it is having minimum disturbance. In the air, this photon is having minimum disturbance. But in the case of glass, it will have more disturbance in its motion. So will its speed decrease or not? Okay. And when it will have again less disturbance, will its speed automatically increase or not? Because it was supposed to go at a fast speed, there was a restriction in it. It is not like being pushed by someone. Light is not like we are pushing the light and then it is going. Light is itself a packet of energy. This energy is automatically moving. Sometimes we restrict it, we control it, okay, and sometimes we even absorb it. But we don't create it. It has been created due to multiple things like nuclear fusion, electrons, and so many things. But this energy is moving as a packet. We can reduce its speed, we can absorb it also, or we can let it pass through. It depends on the nature of the medium. So this speed of the light, it is automatically there. There is one thing which never changes in the vacuum, in the universe, and that is the speed of light. This was in fact a question in UPSC, that why do we choose light for like getting this distance? Why do we choose light for calculation of the distance? Light is one thing which have always the same speed, 3 into 10 to the power 8 meter per second in the universe. If there is no medium, it will always have that inherent energy. Sound cannot pass in universe. It doesn't mean sound is not generated. Sound can be generated in universe, but it is not passing because it requires a medium. Light doesn't require a medium. And not only light, the entire electromagnetic wave, starting from radio wave to gamma rays, they don't require a medium. They are in fact a medium by themselves. If you see them, that when we come to this part, that matter wave duality, so this is a wave which can work as a matter also. That's why light has been called as a matter as well. That generally we assume that it is a wave, but in fact if you see him, it is a packet of energy, and this packet of energy is what we call as photon. So this energy can move by itself. That's why light has the same speed. Its speed can be decreased by change in the medium, but in vacuum it will always have the same constant speed, 3 into 10 to the power 8 meter per second. So light's speed will not change. This is the one and only reason why we choose it for calculation of the distance between the stars or the planets or the galaxies. So this is one part. In notes somewhere you can write it. In notes somewhere you can write this one part. Light always have a constant speed in the vacuum. Light always has a constant speed in the vacuum. It is believed to be made up of packets of energy called as photons. Somewhere there you can write also this one thing, quanta. Initially it was not called as photon. Initially it was called as quanta. And then later on the name changed. Okay. So Einstein never said it photon. Okay. Like Higgs boson is called as God particle, but it was never called as God particle. Just to give you one idea, in 1960s, Peter Higgs proposed Higgs boson particle. For 20 years, no one listened. Okay. In 1982, someone published it. 1980s or end of 1980s. At that time, someone named it God particle. Okay. Then people started considering this as a theory. So initially it was given a scientific name. So no one thought about it. No one considered this theory to be true. But later on, when it was named God particle, so then people started giving attention to it. And Peter Higgs has opposed this, that it should not be called as God particle. But one of his peers, one of his friends, they published it in the name of God particle. They said that you may be brilliant. The other people are not that much brilliant, that they will consider science over God. Okay. So that's why the name was changed as God particle. And then you can see after that Nobel Prize and everything. Okay. In newspaper also you will find, not in newspaper, in news channel you will find it is called as God particle. Normally you will find that Higgs boson is not simply called as Higgs boson. Most of the time the headlines will be God particle. So that's why one thing, people don't pay that much attention to the scientific things. But if you add certain component of God there, then you will find that people may start paying attention to it. This is one thing which happened in case of Einstein also. Initially it was called quanta. At that time there was no existence of quantum theory, so no one paid attention. Later on it was called as photon. So then people started considering it. So this is one part you have written in notes. Its speed doesn't changes. It is made up of one thing called as photon. Now coming back to this main portion, There is another thing called as total internal reflection. There is one thing called as total internal reflection. Here we have to see another two phenomena. But first we have to understand this one part. First we have to understand this one part, like what is actually total internal reflection. Okay. We see that when a light is passing from a dense medium to a rare medium, it normally goes away from the normal. But what we see that as we keep on increasing this, as we keep on increasing the angle of incidence, then after a certain period of time, okay, after a certain period of time, if we keep on increasing this, then it comes more towards the normal. Okay. There will be a certain point where this light will become almost parallel to the surface. Then after, if we further increase the angle of incidence over here, then this ray of light is going to come back in the same medium. Here in the upper portion we have the dense medium, here we have the rare medium. So this one phenomena where the light rays comes back in the same medium, this is called as total internal reflection. This is called as the total internal reflection. Okay. Here you will find that basically the waves become so much fast and there is so much bending that they will come back in the same medium. Okay. Here you will look at this. The waves are almost going like this. Waves are almost going like this. When they strike the surface, see, when they're striking the surface, here the speed will change. Here the speed will change. This speed, and most of the them are slowly moving. This part is, the upper portion is moving slowly. And this has become fast. So due to the fast movement of this one part, it may happen that the light will in fact start moving like this. It is because of this one angle. Like, try to understand this one thing. See. First, light was coming like this. Then we see that when it strikes here, then there will be, this is the dense medium, this is the rare medium. D stands for dense, R stands for rare. When it is passing through this medium, what will happen here? That it will start moving like this. This part is moving faster, the upper part is moving slower. Why? Because we have just seen in the dense medium, the light is traveling slowly. In rare medium, it is moving faster. Okay. Now see this one part. We are having the same surface. We are having the same surface. Now the light is at a more like it is moving like this. It is almost moving like this. It strikes here. It strikes here. Okay. When it is going in this direction, it is going to strike here, right? When it is striking at this angle, the lower portion, will its speed increase or decrease? It is dense medium, it is rare medium. So here, the lower portion, will its speed increase or decrease? It is going to increase. So this one will start to move at a faster rate, whereas the upper one is moving at a slow rate. So angle comes where it is moving in such a manner that the lower portion comes in the upper side. Okay. So here the rays will bend like this. Here it will bend like this. that it will come in the upper portion. So it can happen only when the light is moving from dense to rare. It will not happen in the second case when it is moving from dense to rare. Okay. You can check it from your side. Like suppose it becomes slow. When it is going from dense medium, it is becoming slow here. So this side is always going to go up. This side is not going to go down. This portion is going to move at a faster rate. So it will always bend in this manner. It is not going to reverse back and come here. So that's why when we are moving from a dense medium to a rare medium, the ray of light may go back in the same medium, and this is what we call as total internal reflection. This is what we simply call as total internal reflection. So when you consider light to be a wave, you will find solution for each and everything. That why does the total internal reflection happens? Why does the refraction happens? If you consider the wave part, you will automatically understand all these things. That why it actually occurs. It is all about the wave front. One front is moving fast, one front is moving slow. So we have to see just one thing. We don't have to make the wave front in the exam. We have to just understand one thing, that when it is moving from a dense medium to rare medium, it comes back in the same medium. It will return back in the same medium. And when it returns back, it is called as total internal reflection. Now one thing. So this is one of the properties of the light, that when it is going from dense to rare medium, after a certain angle, it will return back in the same medium. Tell me one thing. Here we are having an area. This is a road. There is the time of month of June. The temperature is 45 degrees Celsius. Heat wave. Okay. So there is a time of 45 degrees Celsius. This is a concrete road. It may specify it more. This is a concrete road. Now in this case, will the road become heated? No. It is going to become heated. If the road is heated, if the temperature here is very high, the air which is moving here, will it also get heat? So what we see that in summer condition, the air which is lying just near the surface, it is going to become, this air is going to become more heated. The upper air, it is going to be relatively colder. It is going to be relatively colder. The air which is here, it is going to become hot, extremely hot. Now one more part. There are two air, one is cold and one is warm. Which one is going to have more density? The one which is cold, it is going to have a higher density. The one which is like warm, this is going to have lower density. Correct? Yeah. We know this part, that cold air is having more density, warm air is having less density. Here we are having a plant. Here we are having this one plant, and a person is here. A person is just standing over here. If the person is looking at this image, at this tree, you will find that light from this tree is going in all the direction. It is going in all the directions. It is coming downward also. Light is coming in this downward direction also. Now here the medium is dense, here the medium is less dense, or you can say it is rare. This medium, this air, it is rare medium. So we are having a condition, where the light is passing from a dense medium to rare medium. Here it is passing from dense medium towards rare medium. So can we have total internal reflection here? We have seen just this one part, that total internal reflection occurs when the light is moving from dense medium to rare medium. Here also we see that the light is passing from the dense medium, the cold air, to the warm air. So when it is going from this medium, from here, the light will reflect back to this person. The light is going to reflect back to this person. And we follow this one rule, that we see the things always in straight line. We always see the things in a straight line. So when the light is coming from the lower portion, so then we will try to imagine that there is something over here and the tree will appear to us in this manner. It is not shadow. It is not a shadow. The tree will appear to us in an inverted manner towards the ground. You may have seen that when you are driving on highways, when you are going on, like going with bike or car or anything, when you are moving on highway, you might be able to see some water on the roads. So why those water? Water is there in the cloud. It is the image which is formed of water in the cloud. If there is a cloud over here, it is having water. The ray of light is coming towards this direction. It will reflect back. Let me draw it with other color. Okay. The ray of light is coming from this cloud towards this area, and this one will also reflect back. It will go into this person. The person will assume that here we are having a cloud also, or we are at least having water. Water is present in atmosphere, but we see it on the ground. In the desert areas, in the highways, when we are looking at these things, they are called as mirage formation. This is called as mirage formation. And the mirage formation is due to total internal reflection. Okay. So whenever you are seeing a tree in an inverted manner, or whenever you are seeing the water on the roads, is that a reality? That is an optical illusion. Okay. So whatever you see around you, most of the things are optical illusion. The color is optical illusion. The twinkling of stars is optical illusion. The color of the sun is optical illusion. The color of a sky is optical illusion. Sunlight? Advanced sunrise and delayed sunset, that is optical illusion. Okay. Rainbow is optical illusion. We will see that also later. Okay. So I am just explaining this once again. See this one part. Look at this one by one carefully. We have seen the upper portion is a cold air. The lower portion is warm air. Why warm air? I have given you the condition. It is June, 45 degrees Celsius, concrete road. Okay. So it is going to become very much warm. When there is too much hot or too much warm air, it will have lower density. So upper portion is having higher density, lower portion is having rare density or lower density. Now we have got a condition that the light is passing from this dense medium to rare medium. So when the light passes from dense medium to rare medium, there is a possibility. It's not that it will always happen, but there is a possibility that there can be the bending back of the light in the same medium. The light will return back in the same medium. And this one phenomena gives us the formation of mirage, like the inverted tree or the water which is there in the sky may be visible to us on the road. So that's why we see the water on the road or in the oceans. Sometimes, in the case of desert ecosystem, people also think that there is a lake in the middle of the desert. So that is the most tragic part. That is the most tragic part in the case of desert ecosystem. Now suppose that someone is stuck in the middle of Thar desert or Sahara desert. Now, due to optical illusion, they are seeing this one part that there is a desert in the middle of ocean. Sorry, in the middle of, there is a lake in the middle of desert. There is a lake in the middle of desert. So they will be thinking that maybe there is water present there. They will start running toward it, and when they reach it there, they will find there is no lake. So this is the most tragic optical illusion. So then they will be cursing physics. Okay. But why this optical illusion is taking place? So write about this total internal reflection. Write down total internal reflection. Yes, OSIS formation. When light rays passes from, when light rays passes from a dense medium, a dense medium to a rare medium, then there is a possibility, that at higher angle of incidences, at higher angle of incidence, then there is a possibility that at higher angle of incidence, the ray of light, the ray of light may return back, the ray of light may return back in the same medium. The ray of light may return back in the same medium. In the same medium. This is called as total internal reflection. The formation of mirage, the formation of mirage in desert areas, is an example of total internal reflection. Is an example of total internal reflection. I hope you have made the diagram. This is optional. You can add some fruits to it as per your choice. Okay. So write these conditions also. Along with the diagram, write these things also. That here we are having concrete, this is June, air becomes heated, at ground level. So this is one thing called as total internal reflection. Okay. Now there is also one thing called as rainbow. Okay. But before we see this rainbow part, there is one thing called as the dispersion of light. Okay. And there is also one thing called as scattering of light. So we will see both these phenomena and then we will come to the applications. Okay. So there are two simple things. One is called as dispersion. One is simply called as dispersion. The dispersion is, I think, some common thing which all of you have read, that when light passes from a prism, then it breaks down into its 7 colors, the name of which are So this is one thing called as dispersion. When the white light is passing through a prism, it separates into, or it breaks down into its 7 component color. That is what we simply call as dispersion. Now the thing is, why there is a dispersion? Basically, the light which is there, the white light which is there, it is made up of 7 colors. All of these 7 colors have different wavelength, different energy. And as per their energy level, there is going to be different angle of diffraction. Yeah. It is a refraction only. Sorry. It is a refraction only. But this refraction is causing 7 different colors. That's why we call it as a dispersion. So dispersion is a special case of refraction. There is a refraction of each and every ray of light at different angle. Then the resultant phenomena occurs to us in form of dispersion. Okay. So why do they like go through it? Now, if you have understood this one concept that light is a wave plus all the 7 colors which are there, they are 7 different wave. They are not one wave. They are 7 different wave. So in fact, when you see this, you can assume this one part. Then when a light is incident, we see that within that light, there are 7 different colors. I am not color coding it, but see, there is also red here. There is also yellow here. This is orange. Then you have yellow also. Then you have blue also. So just take 4 colors. Let us say there are 4 colors. Rest you can assume by yourself. Violet, indigo and all. Yeah. So suppose these 4 colors are there. Red, orange, yellow and blue. These all colors, they are having different energy. They are not one single wave. They are having different energy. They are having different energy level. So when they are passing through this medium, when they're passing through the prism medium, what we see that they are refracted at multiple angles. They're refracted at multiple angles. There is lesser refraction in some of them. This is refracted less. The second one is reflected a little bit more. The third one is reflected a little bit more. Fourth, furthermore. Okay. So in this manner, what we see that they have got different energy level and hence they are getting diffracted at different angle. They are getting refracted at different angle. So that's why we see that there is one thing called as dispersion. Remember this one simple thing, when they pass through a medium, there is a chance, not always, but there is a chance that they will disperse into 7 colors. So that is simply called as dispersion. Which one is having highest energy among them? This is red. So which one is having highest energy? Red or violet? We have 7 colors, red to violet. Violet, indigo, blue, green, yellow, orange, red. So which one is having the highest energy level? See, this one is having 400 nanometer. This is having 700 nanometer. Wavelength is greater in case of red. When wavelength is greater, energy will be lesser. Okay. So red is going to have lesser energy, violet is going to have greater energy. Okay. So violet is having the lower wavelength. Violet is having the lower wavelength, red is having the higher wavelength. Okay. So red is not always very powerful. There's the violet rays which are more powerful. But being powerful is not always beneficial. Okay. Being powerful is not always beneficial. We will see that also later. Like, do you see violet color in the sky? Oh, sorry, do you see the violet color of sun ever? But you see the red color. Okay. So red is less powerful, but we are able to see it. Violet and blue are more powerful, but we are not able to see them. Okay. At least in the sun. In the sun, you don't see the blue color. In fact, the stars which are having more and more heat, they will appear blue. The stars which are having more heat compared to sun, they will appear blue. The sun appears to us as red, or sun appears to us as orange, sometimes yellow also. But the stars which are more and more powerful, which has greater energy, will appear as blue or violet. So that is one part. If you see the bigger stars, we will see that in universe part. The blue is having, or the violet is having more energy as compared to red. So any object which is more heated will release blue light instead of red. Just see this one part. When you are burning gas, what is the color? Blue. And when you burn the wood, which one is having more energy? Gas stove or the gas stove or the wood which you are burning? Which will release more energy? Gas stove. And when it is burning more efficiently, when the gas is burning more efficiently, it gives the blue color. When your gas stove is not properly serviced, when there is too much impurities in it, it will start giving yellow or reddish color. Okay. So more energy, blue light. Less energy, red light. Okay. Now see here. So this is one thing which we know, that dispersion causes, like in the case of dispersion, the light is getting dispersed into 7 colors. The visual light, the white light, is getting dispersed in 7 colors. There is another part. We will see the rainbow pattern later. There is one single thing called as scattering. Scattering of light. Now, what is the scattering of light? When the light is coming to us, it is passing through the atmosphere. It is passing through this atmosphere. And scattering is basically telling us about the deviation in the path of the light. It has been scattered. It has been moved to different direction. It has been deflected to different direction. That is what we call as scattering. So suppose that when the light is passing through any medium, it is finding any obstacle. When the light is passing through any medium and it is coming across any obstacle, then sometimes the light is scattered or deflected in a different direction. And sometimes it is able to pass it. So here also it depends on the wavelength. It also depends on the wavelength. Okay. Now in the case of blue light, you will see that there is a small wavelength. In the case of blue light, you will see that there is a small wavelength. Whereas in the case of red light, you will see that the wavelength is longer. So this red light is able to pass most of the items, most of the dust particles. It is able to easily cross them. It is not getting deflected by them. It is able to cross, like suppose there are dust particles, it will be able to cross many of them. But the blue light, if you look at this, it is having so much a small wavelength that if obstacles are coming, many a times it will be interacting, it will be colliding with that obstacle and will go in different direction. Okay. It will go in different direction. So this light which is there, the blue light, when it is passing through a medium, it will meet many obstacles. But the red light which is there, it will meet very few of them. It is going to meet few of them. It is able to cross most of them quite easily. Okay. So red light is able to cross most of them quite easily, whereas blue light or the violet light, it is not able to cross them. It will not be able to cross the particles. So that is the reason you are able to see the red color properly, but you will not be able to see the blue color coming from the sun. The sun is releasing all the colors. Sun is releasing 7 colors. But in the morning, what is the color of the sun? Never woke up in the morning? At least you may have seen it in pictures. So what is the color of sun in the morning? Red. Now see why it is red in the morning and why not in the afternoon. Okay. Just see this one part. Suppose here there is a person standing over here. We are taking two different positions of the sun. We are taking two different positions of the sun. One is when the sun is near the horizon, and one when it is overhead. Now, just see this one part. Let us change this earth a little bit. A person is standing here on the ground. This is the horizon. Yeah. So when in the morning, when the sunlight is coming to this person, and in the afternoon, the sunlight is coming to this person. Now see one thing. In the morning, when the sunlight is coming to this person, it is traveling most of the distance through what? This layer is called as troposphere. So in the morning, when the sun ray is coming to this person, it is traveling through what? It is traveling through the troposphere. And in the afternoon, when the sun is overhead, how much distance it is going to travel here in the troposphere? How much distance will be there? Maximum 18 kilometer. Like take it, the person is standing directly above the equator. Even if the person is standing directly above the equator, what is the maximum height of troposphere? 18 kilometer. Yeah. Normally it is 13 kilometer only. In the tropics or other areas, it is 13 kilometer. But even if a person is standing on the equator, the maximum height is 18 kilometer. So where do we find the dust particle in our atmosphere? Where is the existence of dust particles? Dust particle is there in the troposphere. It is not in the stratosphere, it is not in the ionosphere. Most of the dust particles are here in the troposphere. In the morning or in the evening, the sun rays are traveling entirely through this troposphere. And during the afternoon, the sun is traveling just this 18 kilometer. So where there would be more scattering? In which case we would have more scattering in the morning or in the afternoon. In the case of morning, here we will see that there is going to be more scattering of the sunlight. Why? Because there are so many dust particles which are here. So many dust particles are present here. Dust particles are still here, but the sunlight is traveling only 18 kilometers. Now think about this. For sunlight, what is 18 kilometer? Sunlight travels 3 lakh kilometer per second. Sunlight travels 3 lakh kilometer per second. So 18 kilometer is not even like fraction of a second. So in that case, there is going to be minimum scattering over here. So when you look at the sun in the afternoon, you will find that it is appearing more as white. Okay. It is appearing more as white. But in the morning and the evening, when it is passing through this entire troposphere, we will see that almost all the colors will be scattered other than the red. The red is having the highest wavelength. See here, red will be moving like this. Whereas the blue light or violet light, they will be moving like this. So blue, violet, indigo, or all other colors, they will be scattered. Blue light will be going in different directions. They will be going in different direction. But only the red light will be coming to this person. Red light is having greater wavelength. and hence they will be able to reach to this person, and the person will see the sun as red color. Now, when you look at the sky, the sky is having dust particle, and the dust particle are scattering the light, mostly the blue light and violet light. So light which has been scattered here, like when it is going here, this light will also come to you. When it is scattered here, it is also going to come to you. So when you look at the sky, what color it will have? Because the blue light is scattered most in the sky, but there is violet color also. When you look at the sky, generally when you look at the sky, you will find that it appears blue. Okay? But there is violet color also. So why not the violet color? There is more scattering of, in fact, violet color and blue color. Violet is scattered most. Violet is having the smallest wavelength. Even indigo color is also getting scattered. Even indigo is also getting scattered. So there is a scattering of violet also, indigo also, blue also. But we see that the sky appears to us as blue. So why only blue color? It is due to problem in our eyes. Okay. Our eyes have a limitation. In the case of human eye, there is a cell which is responsible for identification of color. And that cell is called as cone cells. Okay. In our eye, there is one type of cell which is called as cone cell. This cone cell is able to identify the blue color perfectly, but it is not able to identify the violet and indigo with that much precision. So here the precision of the eye to identify violet, indigo is on the lower side. Okay. But it can identify the blue color more properly. So that's why even though the sky is having violet also, indigo also, and blue also, but we see that it appears to us as blue. So that is also an optical illusion. That is also an optical illusion. Sky is not blue, sky is not black, sky has no color. There is no sky. Okay. In fact, there is no sky. Okay. The sky is the limit, so there is no limit. Okay. So there is no sky, in fact. It is the dust particle which are scattering the lights to us, and we assume that the sky is blue. In fact, there is no sky. When you go beyond the troposphere, the sky will appear to you as black. When you go beyond this troposphere, the sky will appear simply as black. Black means no color. Black is not a color. Black means no color. Okay. So when there is no color, it appears to as dark or black. Okay. So that's why sky, when you go in the space, sky will look like simply as dark or black. But in the lower part of the atmosphere, it will appear to us to be blue. In fact, there is no such color, there is no sky, but it appears to us because of the scattering. So why the sea appears to be blue? Have you looked at the oceans? If not in real, then at least in images you may have seen this. There is also a song dedicated to sea. There was a song also like earlier, Blue Hai Pani. Okay. So why is the pani blue? Whenever you will go to the sea, whenever you plan for your Goa trip next time, okay, go to the sea, like try to take some water in your hand. Just look at this. It will look like ordinary water, having no color. When you put that in your hand, there will be no color. But when you look it from a distance, it appears to be blue. So why it appears to be blue when you are looking at it from a distance, not like when you are near it. When you are looking at from a distance, or when you are also looking at from the sky using uh, like satellites also, it will appear to be blue. So why it appears to be blue? Again here, the region is scattering. When you look at the oceans, near the ocean surface, near the surface of the ocean, there are so many salts which are also rising up in the air. The salt particles from the sea is also rising up the air. They are becoming part of the moisture. Like near the sea, you will find water vapor. Near the sea, you will find water vapor. Huge amount of water vapor, humidity. At the surface of sea, you will find huge amount of water vapor. This water droplets which are there, this water droplet which is there, like suppose where here we are having a sea, here we are having a sea, there are water droplets hanging in the air here. These air droplets are also having salt particles inside them. These water molecules which are hanging in the atmosphere, they are having some amount of salt particles. So these salt particles, when the rays will fall on them, when the rays are falling on them, here again scattering will take place. Here also a scattering is going to take place, and here also violet, indigo and blue, they are going to be most scattered. So when we see it from distance, they will appear to be blue. But when you actually take the water of oceans, it is having no color. So water in fact has no such color, because water is able to let the light pass through it. Water is allowing the refraction of the light. So water has in fact no color. But due to the combined effect of the salt over here and the water molecules over here, the sea also appears to be blue. But why not the rivers? Rivers don't appear to be that much blue. Very little chances. Amazon may look a little bit blue. But if you look at Ganga river from the top, does it appears to be blue? Or any river, don't see Yamuna, it appears different. Okay. If you see any other river, okay, like Ganga or others, it will not appear to be blue. Okay. It will not appear to you to be blue. Why? It doesn't have that much salt content. This is not having that much of salt content. So this is the reason rivers are having fresh water. If they are having also saline water, they might also show it. But if you look at a very, like suppose if you are looking at Amazon, Amazon is a very large river. In the case of rivers, we have salinity up to 5 ppt. In the case of oceans, we have salinity up to 35 parts per thousand. So that is the difference. But if you are looking at a large water body such as Amazon from a very distant part, then you will still find that blue light may be there. But when you go there to see the ocean, the rivers, it will not appear to be blue. Most of the time you will find that dust particles are there, sediment is there, and sometimes plastic slippers are floating over there, plastic sheets are floating over there. So that is one thing which you will really see in the case of rivers. In the oceans, if you are seeing it from a mountain also, from a distant mountain, it will appear to be blue. If you are seeing from a plane also, it will appear to be blue. So that is the region, the salt content. And due to that salt, it appears blue. Rivers don't appear that much blue. Reflection is not the reason. Okay. Sometimes we believe that it is the reflection of a sky. The reflection of a sky is not the reason. It is the salt content and the scattering which is the reason behind it. So write about this. Green color. Which river is green in color? It is because of algae. Because 70% water, that is why sky look blue. So I think now you get the idea. Sky is not looking blue because of water. Sky is looking blue because of scattering. Yeah. Have you seen the Amazon River? How much wide it is? You are asking why Amazon River will appear blue. Have you seen the extent of Amazon River? Do you know what is the size of Brazil as compared to India? What is the size of Brazil when you compare it with India? It is 3-4 times greater than that of India. Ganga passes through half of India. Like it is passing through like the portions from Delhi up to West Bengal. Okay. This is the extent of Ganga River. Okay. If you look at Amazon, it passes from the part of like the western part of South America, crosses through entire Brazil, and then it goes up into the Atlantic. You cannot compare it. It is very broad basin, and not just the length of it. If you look at the width of the Amazon River, then you will find how much wide it is also there. The Amazon River is not a small river. Amazon region is very like deep also. Amazon River is very wide also. Amazon rainforest and Amazon rivers, they are like enormously large. There is Nile River is longest. So longest is not sufficient. You have to be wide also. Okay. If it is longest, that is not sufficient. We can make a canal from Kanyakumari to Jammu and Kashmir. That will not make it blue. Okay. So you have to be broad also in order to be reflecting that much or scattering that much of light. So write about these two things, dispersion and scattering. Yes, so it is not the color of sea. Sea has no color. Take the water of the sea, you will find there is no color. So write this one thing, dispersion. When white light passes through prism, when white light passes through prism or liquid droplets or liquid, then there is a possibility that the light may disperse into its seven component colors. Seven component colors. Seven component colors. You can write that Vibgyor. Second part, scattering. Second part, scattering. When the light is passing through a medium, then there is a possibility that different components of white light may get deflected from may get deflected plus scattered, may get deflected or scattered in various proportions. In various proportions. It occurs due to it occurs due to difference in wavelength. It occurs due to difference in wavelength. Difference in wavelength of different color of light. Difference in wavelength of different color of light. Of different color of light. For example, if the white light is passing through, atmosphere of Earth, then violet, indigo, and blue color are scattered most. Violet, indigo, and blue color are scattered most as they are having shorter wavelength. As they are having shorter wavelength. Whereas red, orange, is scattered least. Red, orange is scattered least due to longer wavelength. Due to longer wavelength. Change the para, next part. During the sunrise or sunset, during the sunrise or sunset, the sunlight travels a large distance in the troposphere. A large distance in the troposphere. A large distance in the troposphere. The troposphere is having very high amount of dust particles. Very high amount of dust particles. Due to this, most of the color of white light, is scattered away. Most of the color of the white light is scattered away, and the red light reaches to the observer. The red light reaches to the observer. Hence the sun appears to be red. Hence the sun appears to be red. In our atmosphere, next point, in our atmosphere, the particles scatter mostly violet, indigo, and blue color. Violet, indigo, and blue color. The cone cell of human eyes, the cone cell of human eyes, the cone cell of human eyes are more sensitive, are more sensitive towards blue color. More sensitive towards blue color. Hence, we are able to observe the blue color of sky. Hence, we are able to observe the blue color of sky. Next part, one more example. Near the ocean surface, near the ocean surface, near the ocean surface, there is presence of, there is presence of water droplets with salt particles. Near the ocean surface, there is presence of water droplets with salt particles. With salt particles. Just to give you one example, like suppose when you are sitting near a river side or even a lake, and if the air is coming to you, you will find that from time to time, you will also witness this, that some water droplets are also striking your face or your body. Like suppose if I keep one bucket of water here, and if the air is moving from this direction, some water droplets will also be reaching you. So these water droplets are also having, these water droplets are also having salt particles in the case of oceans. So that's why near the ocean surface where the wind is also moving, the wind is like causing the water molecules to be present there in the atmosphere in the lower portion near the surface. And there you will find that along with the water droplets, there is also salt particles. So they are going to scatter, they are going to scatter the sunlight. Okay. Write down this thing. Near the ocean surface, there is presence of water droplet with salt particles. When the white light is incident on it, when the white light is incident on it, it scatters the violet, indigo, and blue colors. It scatters the violet, indigo, and blue colors. Due to sensitivity of our eyes, due to sensitivity of our eyes, we are able to observe, we are able to observe the blue color of oceans. So this is one part, like why the scattering happens. There is another thing called as rainbow formation. So why does the rainbow form? Why does the rainbow form? Like just telling you this one part. There is one thing called as sun. There is one thing called as water. There is one thing, a person who is just wandering in the, wandering on the earth. He has not to prepare for anything. So when he is going out, he is seeing some rainbows. Okay. It is that simple. But when you see at the rainbow formation, there are three things which are involved. when the rain, sorry, when there is a rain, whenever there is a rain, there is going to be presence of water molecules in the atmosphere. Whenever there is a rain, there is going to be presence of water molecules in the atmosphere. Now, when the when the sunlight will be incident on this, I told you earlier also that there can be a dispersion if there is a liquid droplet. Okay. So in this case, it disperses the light into 7 colors. So here, first of all, one thing takes place that is called as dispersion. Now see one thing. Here we have water, here we have air. Which one is dense? Water or air? Water is dense? Yeah. So when a light ray passes from a dense medium to a rare medium, can there be a possibility of total internal reflection? Yeah. We have just seen that, total internal reflection. So here we have a dense medium, here we have a rare medium. So there is a possibility that the ray of light will reflect back in the same medium. But then after, it is not necessary that just due to these two things, there can be formation of rainbow. There is a requirement of another thing, and that is now the light has to be refracted here. There's a requirement of refraction at this point. So 3 things has to take place simultaneously. First, there should be dispersion. Then there should be total internal reflection. And then there should be additional refraction. Only and only then after this person will be able to see the rainbow in the opposite direction of the sun. But this will not take place always. This is going to take place in a limited zone. When the rays of light are incident on the water droplet at nearly an angle of 41 to 43 degree. This is the fine line, this is the fine angle on which if the light is incident, then we will see the formation of rainbow. Okay. So for all the 3 things to occur, there is a particular angle which is required. If the sun rays are falling on this water droplet at near about 43 degree angle, only in that case, we have the formation of rainbow. If suppose there is another droplet, if here the sun is making a 30 degree angle, there will be no rainbow. There can be total internal reflection. There can be even dispersion, but there will be no rainbow, because rainbow will happen only when this light will come to the person. It is all an optical illusion. So for optical illusion to take place, the light has to reach here. Now suppose that if the light is going in this direction, after dispersion, a person is here. A person is standing here. The light has dispersed and it is going in this direction. Will this person see the rainbow? The light has dispersed. It has broken down into 7 colors. A person is standing here. Will that person see the rainbow or not? The person will not be able to see the rainbow. Why? There is one simple reason. How do we see the object? When there is a reflection. Is there any total internal reflection here? No. Okay. There is dispersion, and then after dispersing, the light has come to this person. So if there is a no total internal reflection, we will not be able to see the rainbow. So 3 things are required together. 1, dispersion, then total internal reflection, and the third one, refraction. If all these 3 things are taking place simultaneously, then only we will be able to see the rainbow. Otherwise not. In 2013, UPSC has asked only this one question, that which of the following are responsible for rainbow formation? There were 3 options: refraction, dispersion, total internal reflection. Answer was option D, 1, 2, and 3. Okay. So it was a question in 2013. Okay. At that time, if you have given the exam, rank 1. Okay. Straight directly from the prelims. Okay. So that was like in 2013, 14, 15, 16. That was the time when UPSC had changed the format. At that time, questions were quite simple. Okay. So you missed it by 10, 12 years. If you can go back in the time, you have still some possibilities. You can invent a time machine, you can go back in the time, and then you can clear it. Okay. So when you invent the time machine, why will you go back in the clearing for UPSC? Then you have other options also. You can contact Vijay Mallya. Okay. There is more money in that. Or you can go for PM also. Okay. Like you can go and contest for the PM election also. You can change something in country that only this person can be elected as PM after 30 years. Okay. So you can go back to 1949. You can ask the constitutional makers to make a special provision for you. Okay. There are many possibilities after time machine. So in case of rainbow formation, there are three things which are required. One is total internal reflection, dispersion, and refraction. We will write about this in the next session. Okay. Now you can ask your question. So today you have been asking question throughout the class. I have been giving answer to your question throughout the class. बारिश के समय बादल उड़ जाते हैं. देखो बादल उड़ते नहीं है. बादल is also what? It is a wind only. When you see the cloud, cloud is what? Cloud is just a moisture which is floating in the atmosphere. It is an air mass. Okay. You may have read this one concept of air mass. So cloud come to you via this air mass only. The air mass rises in the Indian Ocean. It is transported to you through the southwest winds. It comes here, then it causes the rainfall. So cloud is always floating. What is difference between total internal reflection and normal reflection? Normal reflection is like, suppose when the light is incident on any surface and it is getting back, it is not trying to cross. There is no such thing like refraction which might occur. Like suppose this is a wall, and on wall there is no such chance of refraction. So here the light will come back in the same medium. That is simply our reflection. When the light is trying to pass from a dense medium to rare medium, then due to this angle part, the light bends back in the same medium. We have seen that part also, that why it bends back. That is total internal reflection. Sometimes clouds seen white color. It is because of reflection. Anything which you see, any color which you see, it is because of that reflection of light. Any color of the sky which you see, it is either due to a scattering or due to reflection. There are two things which are responsible for it: scattering or reflection, the reflection of light. Diamond shining is an example of total internal reflection. Okay. That within the diamond or optical fiber also works on this principle. Sometimes rainbow appears light in color. What is light in color? You want deep red, dark red, and other red. It is about the brightness of color which we receive from there. Normal reflection occurs on opaque surface. That is part. Normally we see that when they cannot pass the medium, that when there is an opaque substance, they will come back. That is simply reflection. And when they can pass the medium, then we see that. And even if they can pass the medium, but due to the angle they are coming back, that is total internal reflection. We will see this part tomorrow also, Manorma, that why the TIR, dispersion, and reflection take place simultaneously. Like there is a particular angle on which it takes place, around 43 degree. If the light is incident there, then in that situation, it comes back in the same medium. At all other angles, it doesn't take place. It is about the angle of incidence. We will see that. We will see that part of primary and secondary rainbow. We have just seen a basic part of a rainbow. We will see other things also, like what is the shape and size of rainbow? Is it semicircular or like semicircular or full circular? We will see that part. We have to discuss that. Can light of any color except white be obtained with pure? Hey, white light is generally consisting of these 7 colors. Now, all other colors which you see, it is a combination of colors. It is a combination of colors in different proportions. Like you know that there are 3 primary colors which you also know, like red, green, blue. That is 3 primary colors. All other things which you see, like this is deep blue, this is a sky blue, this is different shades of blue. So that is like the shades. It is according to the intensity and mixture of different waves. What is the sound of universe? There are multiple sounds of universe, but listening to them is the main challenge. What is sound? Sound is created due to vibration. So vibration can produce different type of sounds. There is not one type. There are multiple types of sounds which are generated. Will refraction occur on both transparent and translucent surface? Yes, like apart from the opaque surface, you will find that there is some refraction which may occur in totally transparent objects or translucent also. बादल क्यों चमकते हैं? बादल क्यों चमकते हैं उसको हम लोग बाद में देखेंगे. I have told you that we have to see the thunderstorm topic. So in thunderstorm we will see this. बादल क्यों चमकते हैं? That is not light, that is electricity. When you also create a spark between 2 wires, when you create a spark between 2 wires, then also you will find that lightning or that चमकते हुए बादल. Okay. Any other question? Refraction can occur in petrol. Try to like, can you see through petrol or not? Like when you are having petrol in one bottle of, can you see through it? Anything which you can see through, it means refraction is taking place. If you want to experiment, just take one such bottle, try to see through it. If you are able to see any light through it or any object through it, it means refraction is taking place. Refraction and scattering of light having common, how refraction will have common characteristics? Refraction is when light passes through a medium and it bends, that is refraction. Scattering is when it is incident on surface and it goes in a different direction. That is a scattering. So they are different things. Okay. Sound, we have not read it. When we will discuss the sound, then we will come to it. Okay. So we will see the next part about rainbow in the next session. Okay.